Number 11. The function f of x equals 3 times 4 to the x power was replaced with f of x plus k, resulting in the function on the graph below. What is the value of k? So in this case, what we need to do is we need to plot the function that they're giving us, and then we need to see what the change is. So in order to plot this function, what we're going to do is we're going to find its y-intercept. And to find its y-intercept is where x equals 0. So we're going to plug 0 in for x. So we're going to take f of x equals 3 times 4 to the x power. And for x, we're going to plug in 0. Once we plug in the 0 for x, we're going to get f of 0 equals 3 times 4 to the 0th power is 1, so 3 times 1. So f of 0 equals 3. So our y-intercept is 3. So I can plot our new y-intercept on the graph. Once we graph the y-intercept, we have to count the difference between our original y-intercept and our new y-intercept. In this case, the y-intercept doesn't change, so my k equals 0. 24. Sarah did an experiment to compare two methods of cooling an object. The results are shown below. Which statement best describes her results? So the question here is, if you read the answer choices, it's wondering if it's an exponential graph or if it's going to be a constant rate, which would be a linear graph. So we just need to remember the difference between exponential and linear. Linear changes at a constant rate, and it's an addition or subtraction pattern on your y values. The exponential graphs change by a multiplication or a division pattern. So we need to check both patterns and see which one is true. So on this side, it looks like we can go from 50 to 25 by subtracting 25. But if we subtract another 25, we'd get 0 and not 12.5. So it looks like it's 50 divided by 2 here to get 25, and then divide by 2 again, and we get 12.5. And if we divide that by 2 again, we get 6.25. We divide that again by 2, we get 3.125. So it looks like method 1 is exponential. If you look at method 2 and check the change, it looks like from 50 to 45, if I subtract 15, that works. If I go from 45 to 42, subtract 5, that was my mistake. It is subtract 5. So we subtract 5 there. 45 to 42 is minus 3. 42 to 38 is minus 4. And 38 to 35 is minus 3. So we see on this side, it is a subtraction pattern, but it is not constant. So we're not really sure what type of graph that is right now. And it may be a quadratic, the way it's looking, but we're not sure. So let's look at our answer choices. A, the temperature using method 1 changed exponentially. B, the temperature using method 1 changed at a constant rate. C, the temperature using method 2 changed exponentially. D, the temperature using method 2 changed at a constant rate. So our answer is going to be 1 because it changed exponentially because it's a dividing pattern. 38. The value of an antique radio is modeled by the function v of t equals 150 times 1.004 to the 1/2 t. where T is the number of years since 1965. Approximately what percentage rate is the value of the radio increasing each year? So in this problem, what we really need to do to find that approximately what percentage rate the value of the radio is increasing each year, we need to take the 0.004 and we need to multiply it by the 1/2. So we're going to do times 0.5. When we do that, we get 0.002. And to change that to a percent, we move the decimal place 2 places to the right. And we get 0.2 or 0.20%, which is answer choice B. And we're done.